Hi everyone, this is Mrs. Snowbeck. Today we are going to do Unit 7, Notes 1, and we're going to learn some stuff about circles. And so let's start with some vocabulary. And first of all, a circle, you know what a circle is, but here's the mathy definition. It is the locus or set of all points in a plane equidistant from a given point called the center. In other words, if you have a circle, this point in the center, the distance from that point, so like from here to the edge, whatever that is, it's going to be the same all the way around, no matter where I put it in the circle. All of these would be the same length, okay? And to name a circle, what you do is there's a little symbol. It's a circle with a dot in the middle, and then you use the center letter. So if you look at your drawing over here, see how C is in the middle? Well, C is going to be the name of this circle. So I would call this circle, Circle C, because C is at the center. Now, a second way to name the circle, if you forgot what the symbol was, you can also write out the word. So I'll just say, or you can also write out the word circle, and then you still use C, the center letter. So you can use the symbol or the word. Next, let's talk about a radius. Well, remember that distance from the center to the outside edge? That's all the same all the way around the circle. That's a radius. A radius is a segment whose endpoints are at the center of the circle and on the circle. So if you look at our example over here on the right, I'll erase this one. We don't need this one. But if you look at the other given circle here, let's name a radius. So one radius could be right here, goes halfway across the circle. One could be right here, and one could be right here. So there's three of them that are drawn in. And the way that I name those is I use a segment bar. So like the first one I could call segment either DC or CD. I usually do it alphabetically. So I could call that first one right here, that could be segment CD, and that's a radius. I also have CF, segment CF, and I also have segment CE. So all of these, CE, CF, and CD, are radii of the circle. Now the plural for radius is radii. I don't know if you've ever heard of like cactus, cacti, fungus, fungi. Radius, radii. So it's spelled kind of weird. It's like this, R-A-D-I-I. That's the plural if there's more than one. All right, next we have chord. Now a chord is a segment with endpoints on the circle. So let me highlight a chord here. This right here in yellow, that's a chord. It goes from one side of the circle to the other side of the circle, and both of its endpoints are on the circle. So an example would be segment AB. Now, technically, segment DE is also a chord. If you look at segment DE, that's also a chord, but that's kind of a special chord because it also goes through the center. So if you look right here, yeah, it goes from one side of the circle to the other, so it is a chord, but it's also known as a diameter because it goes all the way across the circle and it goes through the center point. So I'll read the definition. Diameter, a segment with endpoints on the circle that passes through the center, and it is made up of two radii. So remember how this goes halfway and this goes halfway? Two radii make up one diameter. Number one, let's name this circle. So everybody take a look and see if you can remember, how do I name this circle? Well, remember, use a little circle symbol, and then the point at the center is P. So this would be called circle P, and I just write the symbol. Next, let's talk about what's a radius on this circle. Well, there's three of them, you guys, that I see, so you can choose any of them. You could choose LP, PN, or PM. Those three all work. So you can call it LP or PL. So one radius I see is segment PL. One is segment PM, and one is segment PN. Remember, a radius goes halfway across, and they will all be the same length. They'll be congruent to each other. Okay, next, we have diameter. Can you remember what a diameter is? So a diameter, remember, goes all the way across the circle and it has to go through the center. So it would be like this green one. So then that is segment LN. Notice how I'm putting that little bar above the two letters? You have to do that. That's the segment bar, and that's how you would label it. All right, last one. Let's try chord. So when you look at this picture, can you name a chord? If you're kind of thinking MN goes from M to N, from one part of the circle to another part of the circle, you are correct. Segment MN is a chord. Okay, I'm going to now have you pause your video and try number 2 on your own. When you're done, unpause the video. Here are my answers for number 2. I had the name of the circle was circle E. The radii, there's 3 of them, so you could use any of these 3 segments with the red tick marks on them. You could say EH, or if you have those reversed, you could also call it HE. You could have EF or FE, or you could have EG or GE. It's okay to switch those letters around. Diameter, remember, goes all the way across the circle, so that's HG. It has to go through that center point, so either HG or GH if you reversed it. And then a chord would be JK or KJ. Number 3, if QV is 4, what is the diameter of circle Q? All right, let's find QV. Everybody find QV on the picture. And let's put a 4 on that for now. If that distance, that radius, is QV and it's 4, what's the diameter of the circle? Well, all the way across the circle is going to be 4 plus 4, or in other words, 4 times 2, twice as long as the radius. 8 would be the diameter. Okay, let's erase those numbers. We got to have some new numbers for this next problem. So erase those off of there. Number 4, if TU is 14, what's the radius? Well, TU goes all the way across, so what would we have to do to that to get a radius? This time we'd have to divide by 2. So the radius will be half as big as the diameter. Number 5, what if you have a diameter that's 10? What will the radius be? So think, what if your diameter all the way across the circle is 10? What's the radius? Divide it by 2. It should be 5. Because remember, a radius is going to be this part and this part. That blue part is a radius. Okay, number 6. What if a radius is 5x? What's the diameter? So imagine you have a circle and your radius is 5x. How far would the diameter be? Remember, diameter goes all the way across. So it's like having 2 of those. So it's 5x times 2. What is 5x times 2? Well, 5 times 2 is 10, so it's 10x. Next, let's talk about circumference. Now, circumference is the distance around the circle. So let's just jot that down. The distance around the circle. The distance around the circle. So there's 2 formulas, and it's kind of cool how it works. The first formula is diameter times pi. Now you might be thinking, pi, that sounds familiar. Well, pi this is how you calculate it. You take a circle and you measure the distance around the outside of that circle, and then you divide it by the distance across the circle. So if you take the circumference and divide it by the diameter, you get pi. And you might be trying to remember, what is pi again? Well, it's approximately 3.1415926 ... It goes on forever and ever and never repeats. Isn't that crazy how decimals can do that? So again, if you take the distance around the circle, the circumference, and you divide it by the distance across the circle. So imagine if I took this distance right here, that blue distance, and imagine if I had maybe it was a pipe cleaner, and I could put it so that it goes around the part of the circle, and then there's another one around this part of the circle, and then there's another one around this part of the circle, and I had to have just a little bit left for right here. So it would be 3 full ones plus a little bit more. It would be 3 full ones plus 0.14 more. So kind of cool. Now the other formula for circumference, you can do diameter times pi. And let me show you why that is. You know how if you take circumference divided by diameter, it equals pi? Well, what if I go times d times d? Since that was on the bottom of the fraction, it will cancel out. And then you can see circumference is diameter times pi, or pi times diameter. But remember, diameter goes all the way across your circle, right? Here's your diameter up here. Well, that's the same as 2 radii. So another way that people write this formula is 2 pi r. So the 2r is basically the same as 1 diameter. So this would be an r and this would be an r. Number 7, if RT equals 10, okay you guys, let's find RT. Looks like it goes all the way across, okay? So our diameter, I'm just going to jot that down. Our diameter is 10. Find the circumference of circle V. Well, remember what we said before. Circumference is diameter times pi. If our diameter is 10, then it's just going to be 10 times pi. Now, they want our answer 2 different ways. They want an exact answer and a rounded answer. The exact answer is we just leave it with the pi in the answer, 10 pi. The rounded answer means you have to grab your calculator and you're actually going to type in 10 pi. Now, there should be a pi button on your calculator. So if you're using a phone calculator, you might have to turn it sideways. If you're using Desmos, look around on there for a pi button. But somewhere on there should be a pi button, and do 10 times pi. And if you're doing it correctly, you should get 31.4. 31.4. And that would be rounded off because whatever was on your calculator screen, you rounded that off. Let's try another one. Find the circumference of a circle with a radius of 2.5. Okay, so we have a circle and the radius is 2.5 centimeters. Now remember our formula, circumference is diameter times pi. Well, if your radius is 2.5, what's the diameter? How far is it all the way across? Well, you'd have to take 2.5 times 2, which is 5. So your circumference is going to be diameter times pi, so it's going to be 5 times pi. So our exact answer is 5 pi, and I guess since this one has a label, we should put centimeters. And now if I want the rounded answer, I'm going to have to grab my calculator and type in 5 pi equals, and when I did that, I got 15.7 centimeters. Number 9, an asteroid hit Earth and created a huge round crater. The scientists measured the distance around the crater as 78.5 miles. What is the diameter of this crater? Holy smokes, this did some damage, you guys. The distance around the crater, so all the way around here, is going to be 78.5 miles. That's huge. Hopefully that never happens in Farmington, right? And we want to know what is the diameter. So we want to know what is the distance across that circle. Well, think about your formulas, you guys. We know the distance around is called circumference, and circumference is diameter times pi. So let's plug in what we know. We know the distance around the circle. And so the 78.5 is going to go in for the C, the circumference. So 78.5, we do not know the diameter, so we'll leave that D, and pi stays pi. Think about how would you solve this for D? How would you get D by itself? Right now it's D times pi. So to undo the multiplication there, we're going to divide by pi. And if we divide by pi, these will cancel out. And I'll be left with D on the right side, and now I'm going to have to go on my calculator and type in 78.5 divided by pi. And I think you get a number like 24.99. If you rounded that to the nearest tenth, it would be approximately 25 miles for the diameter. So our answer is either 24.99 or 25 miles. That's a long way across that crater. Nice. So now you guys are going to try Unit 7, Practice 1. If you need help, please ask. That's what we're here for, you guys. Have a great day.